Hi folks, this is a solution for number 14 on page 39. So what they give us here is the equation of a general quadratic function. Okay, and they want us to find values for a, b, and c that satisfy these three conditions. Okay, now first of all, notice that you've got three unknowns that you're looking for, a, b, and c. So it makes sense that they have to give us three pieces of information. So info 1, they tell us that f at 0 is equal to 0, and then they give the value of two limits. Okay. So hopefully with these three pieces of information, we should be able to find these three unknowns. So let's start with the first one, f at 0 equals 0. Okay. Now, this essentially tells us that the y-intercept is equal to 0. Okay, and we should know that c just represents the y-intercept of this function. But even if you did it, let's just, put in f at 0, which just gives us a 0 squared plus b times 0 plus c, and they tell us that that's equal to 0. These both disappear, so we have c equal to 0. Okay, so we have our first variable solved for. Okay, so that means that f at x can be written a little more simply. Okay, it can be written as ax squared plus bx. Okay, so let's move on and see how we can use these pieces of information. Okay, now they give us the limit of this function as x approaches a particular number, in this case here 1. Well, one thing we know is that this is a quadratic, and we know that quadratics are nice functions. They exist everywhere. They don't have any jumps. They don't have any vertical asymptotes. So it makes sense that this function should have a limit, and that the limit should just be the function value. Okay, but let's see if we can show that algebraically. So let's take here, we've got limit as x approaches 1 of f at x. Okay. So essentially, we're finding the limit as x approaches 1 of ax squared plus bx. Okay, we've already determined that c is equal to 0. Okay, now they tell us that the limit of f at x as x equals 1 is equal to 5. So I'll replace that left-hand side by 5. So now here, let's just see what happens. So here, x is approaching 1. So that means x squared, again, is just going to be approaching 1 squared as x gets closer and closer to 1. So I'm just multiplying this 1 squared times a. So I'm just left with a. Similarly here, well, x is just approaching 1. So this expression is just approaching b times 1. So plus b. And so now we've got one equation that should help us solve for a and b. Let's do the same thing with that other limit. The limit as x approaches negative 2 of f at x, okay, is just the limit as x approaches negative 2 of a times, x squared plus bx. Okay, so limit of f at x as x approaches negative 2. They told us that was negative 8. Sorry, I just noticed here it's positive 8, so let's get rid of that negative here. Okay, and do the same thing. Well, here x is getting closer and closer to negative 2. So x squared is just getting closer and closer to a times negative 2 squared. Okay, plus bx is just going to be approaching b times negative 2. And so this is going to give us a second equation. Okay, so 8 is equal to, this becomes 4a minus b. Okay, so here's equation 1, here's equation 2. Let's bring them together. So we got 5 equals a plus b. And 8 is equal to 4a minus, this here is 2b. Okay, sorry, I forgot about the, it's negative 2 times b, so minus 2b. So here, this is 2b. Okay, let me multiply equation 1 by 2. So that's going to give us 10 equals 2a plus 2b. Okay, and here I'm going to add these two equations together. So 2b and 2b, those cancel out. So here we're left with 6a equals 18. And so a is equal to 3. Okay, and then from the second one here, b is just equal to 5 minus a. So b is equal to 2. Okay, and there we have it. We have our three unknowns. So let's recap here. Okay. This first thing, we just used the fact that f at 0 is equal to 0. That helped us determine the constant term. Okay, and then I used the fact that quadratics are nice functions. So not only do they have limits everywhere, but their limits just approach whatever the function values are at that point. Okay, and then from there, you're just left with solving this system of two equations and two unknowns. Okay, that's it for this one.